Cities like New York have been growing very fast, and with this growth, we have seen an increasing number of autonomous and connected vehicles. These type of vehicles are able to communicate with each other as they're moving from one point to another because they have equipments that enable them to send information between each other. Yet, we still have a question. How can we make sure that these autonomous and connected vehicles are able to improve the safety of pedestrians in urban areas? Currently, pedestrians still account for 22% of the worldwide 1.2 million deaths which are caused by traffic accidents every year. Most of these deaths occurs when the pedestrians are crossing the street, or sometimes because of the poor visibility from the driver's side. My research projects aim at developing an algorithm that will be used by autonomous and connected vehicles to help improve the safety of pedestrians in urban areas, especially in New York City. My research projects aim at achieving this goal by determining the intention of the pedestrian. This involves determining whether the pedestrian want to cross the road or not, and which direction will they take as they are crossing the road. This can be achieved by predicting the trajectory of the pedestrian or simply the path that the pedestrian took while they are moving from one point to another. The prediction of the pedestrian trajectory can be achieved by using a machine learning model known as social GAN. The social GAN algorithm can predict the future path of the pedestrian based on the past path that the pedestrian took while they are moving from one point to another. For example, if we already know that the path of the pedestrian for the last 10 seconds, we're able to predict the path that this pedestrian will take for the next 10 seconds. This is something that will be very important for autonomous and connected vehicles, because having this information will enable these vehicles to know at what point they should brake and let the pedestrian cross the street. And this research project will rely on CCTV video footage which were recorded from different parts of New York City and were publicly available. These videos will help our model to learn the complex behaviors of pedestrians, such as how their decisions on crossing the road are impacted by those around. As a result, we'll be able to make sure that our model best predicts the behaviors and therefore the trajectory of the pedestrian in New York City. So let's look into the results of one of our plots we obtained from the social GAN model. As you can see on the plot, the green point, they show the actual path that the pedestrian took while they were moving from one point to another. And the red point, they show the predicted path that was obtaining from the social GAN model. And as you can see, they are closely matching with each other. This proves that our model is able to predict the path of the pedestrian based on the past observed trajectory that the pedestrian took while they were moving from one point to another. We have also been able to implement the visualization of trajectories of pedestrians in CCTV video footage. This is one of the CCTV video footage that we obtained from one of the streets in New York City. The dotted line shows the future trajectories, while the solid line shows the past trajectories. This visualization will be very important as it will help us to best understand how our model social GAN perform when it comes to predicting the path of the pedestrian in actual CCTV video footage. At the end of this research project, the social GAN model will be implemented in a 3D vision environment known as the color environment. This color environment will be very important for the testing purpose and for the visualization of our model, so that we can know how our model is able to predict the path of the pedestrian in different scenarios. Later on, this model will be used on connected and autonomous vehicles by the New York City Department of Transportation in an effort to decrease the pedestrian vehicle accidents and therefore increase the safety of pedestrians in urban areas, particularly in New York City. Thank you for listening. Thank you.